front. Whoever's phone is buzzing needs to turn it off. Stat. The top of this one says classwork 5.4. That's the front of it. You didn't have to do the classwork piece for homework because you didn't have to do that part. You needed to do the homework 5.4 piece. Okay, so homework 5.4 is what I am looking for. Also, if you have misplaced those papers, they're all available on our website. Okay, so any of the handouts now, so 5.3, 5.4, one from whatever, the one you get today, those are all going to be online. So if you lose them or need another copy, the answer is to get it offline. So some of you have been like, no one in this class, I don't think yet, but has asked like, hey, I misplaced this over some break or whatever, can I get another copy? They're online now, they're there, so get them there. Okay. The other thing I have to tell you is that as part of, just full disclosure, we told you this at the beginning of the year, but maybe you forgot. This class is about like 75% of the stuff is directly applied to building, and then there's this 25% that isn't. So maybe 70-30, whatever, something in there. So if you haven't caught on yet or haven't noticed, we're kind of in a portion that dealing with proof and triangle congruency that doesn't come up a whole lot, that isn't really applicable to the building side of things. It's just one of those things that we've got to do and we've got to get through. Those decisions are not made by us. That's something like at a state level, they say like, in geometry, you should learn this. And that's, I don't fight that battle. I'm just here to make it better for you. So we're working on proof. That's what we're going to finish out this quarter, and probably for the rest of the month we'll be on proof. This is the rest of the year, just so you guys know. So we're going to do proof, finish that, and then the next thing we're going to be doing is learning everything there is to know about circles. So you know area and circumference of circles, and we're going to do all kinds of other stuff with circles. And then the last thing that we're going to do is probability, which will be about counting cards and stealing money. Okay? So it'll be a really great way to end the year. What?
Where are the
Probably never. Just, if we're being honest, I haven't done it yet, so they're out there. Okay. As far as today goes, for your warm-up, so, I am very, very excited about the next portion of class because starting possibly next week, but definitely the week after, if not next week, you guys are going to start building trusses. Now, I want you to try and think back to the very first time you built a truss. It was with that truss on the far right. Look back there. On the right side, remember those like smaller little trusses over there? You guys built those trusses, and I don't know if you recall, but when we held one truss up to the other, they were supposed to match, right? As we looked at them, if you look down the trusses, you could see that some would be like this, and then some would be like this, and then some would be like this, and they weren't necessarily all even, and we kind of giggled about it like, haha, yours is really messed up, and it was kind of funny. It was funny. Now, for each structure, there's going to be, I think if it's right, 7 trusses. There's going to be 7 trusses per structure. There's going to be a truss at the end, and then every 16 inches. I might be wrong on that number, so you can count. But we're going to go into like this mass production of trusses. Now, it's really exciting for a few reasons. One, because mathematically, you guys have gotten a lot smarter over the course of the year. But 2, your skills on the build side have also gotten a lot better. Right? Like yesterday, there were all kinds of great things noticing like, hey, those aren't flush, and they need to be, and you guys would fix it and address it. It was awesome. Your accuracy with measuring has gotten better. Your accuracy with cutting has gotten better. It's way, way better. I don't know if you guys remember the beginning of the year, but whoa, okay? Things are so much better now. So we're going to be building 1428 trusses, and the ultimate goal, and I'm excited to see it, is that all 28 trusses are going to be identical. Right? And they're going to be identical because when we put up 7 trusses over an 8-foot span for the building, and then we lay a piece of plywood on it, that piece of plywood is going to fit perfectly on all the trusses, and it's going to be gorgeous and beautiful. Because we can see now what would happen if we're trying to lay a piece of plywood over trusses that are all wonky-tonk. It's not going to happen. And I have every faith that you guys are going to do it just wonderfully because, again, your skills have gotten much better. So, before we do that, I want you to determine the length of the rafter being the slanty part of the truss, okay? The hypotenuse part of the truss. Now, hopefully you are familiar with how wide the building is. Anyone? 8 feet. Whew. Okay, one of you knows. All right. And you have plans. I will say that you'll need to figure out some information. I'm not going to really say what, but in your tables, you should be able to determine the length of the rafter. You have the necessary plans. You have the necessary math. That's what I want. Okay. So you are working in your teams as necessary. At least one person per table should have a set of plans. And have out homework 5.4 and we'll get started. And we understand what a truss looks like. Is that halfway? Right, so there's our truss, looks something like that. And so we know then that this is 4 feet because we know that half the base is 4. And it tells you in there that the pitch is 5/12. Now I'm writing pitch. Oh, your school's bashed. I'm writing pitch the way that's how you write pitch, right? It's how it's written in there too. And your plans actually kind of tell you a length, but it's not going to be the same length we calculate. So the plans do tell you the length. Did anyone see that the length is on the plans? Awesome. It's on the plans, but one thing I'll say is that if you only wanted to go and like be a carpenter and work and do construction, cool. Like they would probably give you the number, and that's fine as well. If you wanted to be an architect and have a much higher pay grade than a construction, carpenter, then you would probably be calculating the length. There's this pretty common thing of like, if you could use the tool, that's really great. If you made the tool though, you make a lot more money. Not that that's what it's all about, but I'm just saying, like, you guys learn how to use calculators and that's great, but if you could learn how to program calculators and understand this, make your own stuff, that's a much cooler thing, I think, and it gives you a lot more options going forward, okay? So I'm glad that those of you who read plans, that's also a good thing. I hope that at least that means everyone in here should theoretically know the length because you can read plans. That would be the first goal. Okay, anyway, there's a bunch of different ways you can do this. There are a slew of ways, many, many ways that you could calculate the length of that rafter given this. And the way I do it is probably different from the way Mr. Frishy would do it, and is probably a lot different from the way that Mr. Weber would do it, right? Math teacher, kind of a math teacher, and then construction teacher, right? We're all going to have different ways that we do it. But my favorite way, because I want to do it this way, is to look at this triangle. I'm going to redraw my pitch triangle to say my pitch is 5/12. Does anyone know the angle for a 5/12 pitch? The cut angle? What was the cut angle we worked with last time? 11.5. Was that the pitch of that roof? Let's check it out. If it was 11.5, how would I tell? Tangent of 5/12 should give me 11.5 if that's the pitch. Oh man, I'm in the wrong mode. No, I'm not. What happened? What did I do? Oh, inverse. Oh my gosh, what a dum-dum. Inverse tangent. God, amateur hour. Okay, still...
Nope.
No. So the pitch, you might have thought that the pitch of the shed roof was 5/12. It's not. It's not really 5/12 for reasons that were weird. I want you first, before, like side note now, What was the pitch then of the shed roof, those first two structures that have the siding on them? Try and find out. What was the pitch so that the angle was 11.5 degrees? Because a 512 pitch gives you 22.6 degrees. So find out what the pitch was for 11.5 degrees. Find out, go. Be like tan inverse. How about, is it 212? Does that give me 11.5 degrees? No. And then I would see like, oh, it's probably between 2 and 3 over 12. Probably because, right? We're good with that? Okay. That's one way you could go about guessing. Another thing that you can do is you could say, hey, I know that it's going to be tangent of 11.5. I know that's the ratio that I'm trying to get. So I'm trying to get, whenever I do my opposite divided by my adjacent, I get 0.203. But you know the adjacent side, right? You don't know the rise. You know the adjacent side, or the run, because what's pitch always over? 12. So the adjacent side has to be 12. So essentially what you're doing is you have the tangent of 11.5 is equal to opposite over 12, or this number, 234, is equal to opposite over 12. And how do I solve that? Instead of dividing by 12, what do? Multiply. So I could just multiply my calculator by 12, and I get 2.44. And I find out that if I do tan inverse of 2.44 divided by 12, I get very close to 11.5 degrees. Okay. So, I will also say, I think that this works. 2.44 divided by 12 is very close to what Duke was right. The actual pitch, like, of our roof, it was 8 feet on one side and then 10 feet on the other side. Is that right? 6 and 8 over a 10-foot span? Yeah. So, right, we knew Duke was right that it was a 2 over 10 was what we were calling the pitch incorrectly in terms of pitches over 12. And you'll notice that those ratios are still super close, though. Okay, so those ratios are close whether we put it over 10 or over 12, whatever. Okay. All right, that was a side note. Back to the problem at hand. Here's one way you can do this. And the way I want to do it real quick because I want to talk about math. If I figure out the angle for that pitch is going to be the same angle over here. And in fact, we already saw what the angle was for a 512 pitch. If you do tan inverse of 512, you get that the angle is 22.6 degrees, which we're going to call 22.5 on this saw. It calls it 22.5, right? Mathematically 22.6, construction-wise 22.5. So now I have this gorgeous triangle, just beautiful, and I know that this side is 4, and I know the angle, and I'm trying to figure out what that rafter length is. So I could go ahead and use some SOHCAHTOA stuff, some trig, and I could find out the rafter length. Looking at this triangle, what trig ratio would I use to find that side? Mitchell? Why would I use cosine? Got it. Because, yeah, it's comparing the adjacent side and the hypotenuse, right? So that would be cosine. So if I wanted to get super nerdy mathy, which of course I do, why wouldn't I would have the cosine of 22.6 is equal to the adjacent over the hypotenuse. And this is a fun little reminder for you. Cosine of 22.6 is 0.9232. And now what's the problem with this? Mitchell. That says divided by x, but that's not good for me. Awesome. I want to flip both of these. It would be much easier to say that x is on the top. Okay? So I would have this. I would have 1 over 0.9232 is equal to x over 4. Because now the difference is I can undo dividing by 4. I can't really I could, but it's a little confusing. I can't really do undo dividing by x But I can do undo dividing by 4. Because what's the opposite of dividing by 4? Multiplying by 4. So I'm going to multiply this whole thing by 4. And this is a little bit different than I showed you it last time, because I think it might be a little easier for you. So I'm going to figure out what that number is. I'm going to do 1 divided by 0.9232. And I get some number. And that number now, I'm multiplying by 4. So I figured out what that fraction was, multiply it by 4, and I get 4.33 feet for my rafter length. Okay, 4.33. Anyone know what a third of a foot is? Right? So it's going to be 4 feet 4 inches. Those of you who looked on the plans, what did it say the rafter length was? Oh no, you really looked at the wrong thing. Hold on, please. Yeah, what does it say, Chris? It says the rafter length is 4 feet 10 inches, so why is our 4 feet 4 inches wrong? What happened? What's really going to happen when we go build? Mickey? Yeah, there's going to be some eaves, right? We're going to have a 6-inch overhang then on our roof. That's the word I'm looking for. What?
The exact answer is
We'll chat later. Dude. Okay.
the exact number is 4.000105772.
That's the exact number. That's unrounded. Actually, here, I'll give you the really unexact number. 4 divided by cosine of, what was it? Wait. How did I get that inverse cosine? No. It is cosine 5 over 12. No, what happened? Yeah, tangent. Tan inverse of 5 over 12. Okay. Ready? So, 4 divided by cosine of tan inverse of 5 over 12. There's the exact answer. If you can see unrounded, which is exactly 4 feet 4 inches. Yeah, thanks. Okay. So that's the length of our rafter, but we're going to do plus a 6-inch overhang. Okay, so plus a 6-inch overhang. Which would give us, so when you guys are cutting them?
410.
410. Pick your heads up before I lose my mind. All right. Real quick, you guys have 4 minutes to talk about your homework. 4 minutes to talk about your homework. You need to have them all correct, by the way. You're going to be using cards a lot today to share. So 4 minutes to talk about your homework. Ready, set, go. Do you remember who I'm talking about, Mr. Issue? Like, you guys watch, talk amongst yourselves. You're like, so over here, side, and side angle, side. You know? Yeah, it was so bad. Okay, enough of that. Shh. I don't name names. These are... No, he was a good teacher, so all the students passed because no one learned anything. Like these two fools who are going to lose my mind. Tommy and Ethan, if I ask you again, I'm going to ask you to leave. Great, fantastic. I know, we're all hot, it's tired. I know, we get it, okay. Okay, the things, here's the deal. We are going to review the fact, real quick, that I think we're going to start back to what we talked about before break. Before break, we covered this idea that if I know that the 3 sides of a triangle are the same as the 3 sides of another triangle, I can confidently say that those 2 triangles are congruent. And here's why, okay? Because, and I think we all are starting to get this, that like if a triangle, if I give you 3 sides and say like make one side 8 and make the other side 7 and make the other side 12, that creates a fixed triangle. There is only one option for the type of triangle you can make with those 3 sides. And since there's only one option you can make, since it's a fixed rigid triangle, that means if you have 2 triangles that have the same sides, they are of course congruent. And I think we all kind of get this one. Like I think this one makes the most sense. You're like, yes, like of course it is. Okay. That was called side-side-side congruence, right? And we also talked about before break, we talked about this idea of side-angle-side congruence. That if I give you an angle, let's say I have a 100-degree angle, okay, and I say that one side is going to be 8 and the other side is going to be 10. Then I think we all kind of get the idea that this angle right here is fixed, right? I can't move these sides because it's fixed. So if this is 8 and this is 10, then the connection here, there's only one option. And we kind of get that, like there's only one triangle that you can make with those restraints. So that again, since it's a unique triangle, if two triangles have the same side, angle, and side, those two triangles have to be congruent. That we can conclude then that the other angles are the same and that the other side is the same, even without measuring or knowing. Okay, and that one kind of made sense. We talked about two more yesterday, Tuesday, and we're going to write those down real quick. Okay, so we are talking about G6, we are talking about proof, and specifically right now we are talking about triangle congruence. So, triangle congruence. The first one that we talked about yesterday, was this idea of ASA. Angle, side, angle. And this was the task yesterday where we said, okay, so if I fix a side, right, like if I say, all right, there's a triangle and it has, look, I did it over here, a triangle that has an 8-foot side and then one angle is 60 degrees and the other angle is 30 degrees. If these angles in that side are fixed, they're only going to meet in one particular spot, right? Because these angles, they can't change. You can't change that angle and you can't change this distance. So these two have to meet in one particular spot, and they create one unique triangle, the only triangle you can create. That's what this is saying. So it's saying if I have two triangles, right, that have some sort of fixed, they have a side that's the same, and I know that either angle on the opposite ends are the same. So if I know that this angle is the same as that one, and then these two angles are also the same, I know that those two triangles are going to be completely congruent. That they have to be. They're forced to be. There's no other options for triangles you can make. Okay? We talked quite a bit about this one yesterday. The one we didn't talk about very much yesterday, but I'm just going to point out today, is that you also have congruence if you have angle, angle, side. Angle, angle, side. Also, please do me a favor and notice that angle is spelled G-L-E. And you're not talking about angels here. So you're not angels, you're angles. It's okay, you'll work on it. I see a lot, have you ever seen, you should look up there's some weird tattoos that people get because they're like, it says like, Mama's little angle. I'm like, oh. Okay. So angel, angel, there's a difference. Okay, this is angle, L-E. If you wrote E-L, just double check yourself. It's okay, I'm not making fun of you, I'm just trying to learn so you don't get a weird tattoo in your old. Okay. Okay, angle, angle, side would look like this. If I have some triangles, I'm just drawing some random triangles, and I know I have one angle that's congruent, another angle that's congruent. This time, the side we're talking about is not between the two angles. And hopefully here there's a goal that you are seeing the difference between when the side is between the two angles and not between the two angles. There was a lot of confusion about this on Tuesday. Okay. In one way, it doesn't totally matter because they're both show that triangles are congruent, but in another way it does matter because if you say the wrong reason, you kind of, it's kind of like a dumb thing. Okay? So the difference being, right, on angle, angle, side, the side is not between the two angles, right? Hopefully you're looking at this and noticing the difference. Side between the angle, side not between the angle. Okay? All right. Now, that's it. There's 4 of them. There are 4 ways to show that two triangles are congruent. There's 4 ways. Side, side, side. side, angle, side, angle, side, angle, and angle, angle, side. Those are the only 4 ways. But it is worth mentioning, you know there are 2 ways. You don't know yet, but you know one way for sure. What's one way that I know does not show my triangles are congruent? Say again? Yeah, not congruent. If you have just angle, 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 right, like we already know, that does not mean my triangles are congruent. Right, as an example. Just knowing that the angles are the same does not guarantee your triangles are congruent. Are they similar? Absolutely. Is that great? Sure, but they're not necessarily congruent. Okay? Just knowing the angles, not enough. The other one that we looked at yesterday, who lost the bet? Duke. Duke lost the bet yesterday. The other one that we lost the bet on was angle, side, side. Now, here's the thing. If you are ever writing ass on your paper, you should know that it's not congruent because you're not supposed to write ass. Okay. In class, you may write ass otherwise. Okay. As an example, to show that, and remind you guys of what we talked about last time. If I have this triangle, so it would look like this. I have an angle, and I know this side, and I know that side. Right? And here's what we saw on Tuesday, was that this side over here, you can kind of picture this idea of it rotating to be over here. Right? So if it rotated to be over there, then you would have a much different triangle. Where you still have the same angle, the same side, but now that leg or that side rotated and kicked back in. Because if I don't fix this angle between them, I can choose it, right? It can rotate. So that would look kind of like this, if we wanted to draw it out. Right? So where that side can rotate and be in 2 different spots. And since it can be in 2 different spots, we can't say for sure that they're congruent. Okay? All right. It was a long 7 minutes. Okay. With that in mind, I want you to recheck on your homework. You guys are going to be telling me yes or no. Okay? I'll take volunteers on it, but I will reward you with candy if you answer me correctly. Okay? What? All right, don't tell the whole class. Okay. Take another minute. Make sure you use all your reasons correctly, and then we're going to go over my... Right? So because it's angle, side, side, you're not supposed to write ass, so they're not congruent. Right? Because angle, side, side does not guarantee that they are congruent. Okay? That's what I'm looking for. If no one wants to volunteer for one, I'll just do it, and I'll eat a piece of candy. Okay, great. Ready? 2, who wants to go? Paige. How do you know? What do you add? Yep. And you said angle, side, angle? Awesome. Number 3. Ugh. Don't steal anyone's candy, by the way. That's very rude. Number 3, Chris. What are you adding? I only see 2 sides marked.
Yeah, but they share them.
Awesome, right? They share that side, so it's side, side, side. Awesome. Chris is right. Yay. Anyone else? Number 4. Arden.
There is not enough information to tell.
Did anyone disagree? Levi.
I think there's a straight line. The 2 intersecting lines will always result in the same. Well, line segments, 2 intersecting line segments will always result in the same angle on the...
Hit me with a vocab word, somebody.
And
Duke.
how can you tell it's a straight line?
Hold on. Duke, what? How do you know it's a straight line? Oh. How do you know it's a straight line? I'm gonna go with this. Because we aren't dealing with arcs.
That changes nothing.
Also, it
How about if you don't like that they're straight lines because I'm telling you they're straight lines. Because we're dealing with straight lines. Because they're not dealing with arcs. Because the sides of a triangle, like that's like saying, well, I don't even know it's a triangle. Those might be curves. Like we're assuming it's a polygon. We're assuming it's a triangle. We are only dealing with with shapes.
That line could have an angle right in the middle. It's off by 1 degree.
This right here.
No, I mean at that middle intersection
I know.
point, that's 1 degree off.
Yeah, it could, but they're not. So I'm telling you, unless it's a circle, all the lines in here are lines. I'm not trying to play a trick on anyone. So hold on. So they're straight lines because we've been talking about that. And these are like this is my little toy. So again, when I told you about it, like that these are straight lines because they're pieces of wood that are cut on the table saw and are straight. So here, right, what's going to happen to these two angles? We know they're what? Congruent, and the name is what? Right, those are vertical angles. So we do have to add that piece of information and say, hey, these are vertical angles. And you were telling me originally it was what? Angle, side angle. Okay. Vertical angles. Hey.
Wait, I disagree.
Okay, why?
Because the lines on both sides don't have to be the same length. So we can just increase.
Wait, but you have the other ones.
What are you talking about? The lines? These are tick-tickied.
Yeah, see?
Yeah, I know. I
Where
mean,
you
the
get
other
the
ones.
other ones.
Yeah, but
No, you can't.
Are the two?
Because looking at this triangle, this is the idea that if I have a fixed side, and that's what's over there, like if I said that was 8 feet, and this was 60 degrees, and that was 30 degrees, these are only going to meet in one spot because that angle has to be fixed. It can't be like slightly longer or anything.
So those two other angles are congruent.
These two?
No, the other two.
These two?
Yeah.
Yeah. These marks mean the angles are congruent. These marks mean the angles are congruent.
Unless they're, like, obvious
Taylor?
sides.
Wouldn't that make other angles the same?
Yeah, so at this point, I could say all kinds of stuff, right? At this point, now that I know, hey, angle, side angle, I could say, yep, that means these are the same, that means these are the same, that means all the lengths are the same. That's called CPTCC.
Okay,
We'll learn about it later.
okay,
CPCTC. CPC. Corresponding parts of congruent triangles are congruent. Blah. What?
So that triangle shares that one side that goes through?
Yes.
Share the two?
Yes, that's a single line. So like on all these, right? Like on 6, straight line. On 9, also a straight. Those are straight lines. They're not just tilty world triangles. Okay, so yeah, angle, side angle. Anyone want to say 5? Someone I haven't heard from. Mariah. Not enough info. Catch. Right?
What do you mean?
You have to have at least 3 pieces of information. All of them are side, angle, side, angle. There's not enough info. What?
That's not true. Because the two sides on each of the triangles, the side that is opposite the angle is the only one that is the known measurement. Therefore, with that specific angle that is also the same on both triangles, those other two sides can only be one length. Each. Yes.
How about this? We will make this the focus of our discussion next class, and I will gladly show you that. Huh? What? Just knowing that alone, we'll work with it next time. If you'd like to work with the pad and paper in the meantime, we'll look at it. Okay? It's the same thing. Like it's similar to what Duke was saying last class about how if I have the angle side and one pivots over, that it doesn't make one unit triangle. Yeah. So how about this? TBD. Too busy to disorder. Okay, number 6. Stevie. Okay, love it throwing in the vertical angles, but yeah, you fixed it to what? Awesome. angle, side, angle, right? And looking at one triangle, I see that the side is locked in between the two angles, okay? Who's feeling brave on number 7? This is going to be our last one. Someone I haven't heard from. Chris. I'm just sorry. Malachi. Ooh, I said sorry. There's your first one for calling you the wrong name.
I said not congruent because of ASS.
Right. Not congruent. For one reason, because it's, right, we can agree that like the angle here is not between the two sides, and the angle here is between the two sides, so you're not even comparing the same thing. And also, this one is angle side side, which we don't say ass in class. Okay. Great. The other 3 are all congruent. How about that? It's congruent. 8, 9, and 10 are congruent. Spoiler. Sorry, you already have one. Sorry. What? Because we're going to be running out of time.
Oh, okay. You already grabbed yours? Yeah. Here you go.
This isn't homework. Okay. You all have this paper. Last set of my instructions of me yelling at you. First thing I'm going to want you to do, I want you to do 2 things. I want you to use mathematical notation, and I want you to use words. Okay? So, we're going to work on having both of them. This AD congruent to CE, I would like you to mark the fact of whatever piece you're marking, all right? Your mathematical notation should match your words. So, for instance, if I say 2 triangles are congruent because of angle, angle, side, I had better have marked congruent angle, congruent side. If I'm going to say they're congruent because of angle, side, angle, I need to have the appropriate angles and sides marked as congruent. Okay? AD congruent to CE means those are congruent. DC congruent to EB means those are congruent. This is the mathematical notation I'm talking about. And then I want you to use words as well. Down here on number 2, just to point out, this means that they are parallel, as the notation shows. Okay, so those 2 lines are parallel. I want you to tell me whether or not the 2 triangles are congruent. Directions are at the top. Oh boy. Use some words to the right. You have 10 minutes. That's 2 minutes per problem. There are 5 problems. 2 minutes per. Working in your elbow pairs. Do not work alone. Ready, set, go.
Alrighty. I'm a little bit confused with this. I don't think there's enough information to decide. Or
Just what's work? I'm just saying in general, okay? If you thought one was easier than another, okay. Sorry, I was thinking. Shh, quiet. Do you guys anyone want to volunteer to do one? Or do you want me to do that? Okay, I'll leave this all. Okay. Cool. Tell me how Julia did it. I love that.
She said, since C is the midpoint, A to C, C to B, the B to B, side to side.
Great. Can I tell you this? Here's what I love. I love this. Julia. Ethan. I love this teamwork because you know what? Ethan maybe not, he was saying like maybe I didn't even know how to do it. He just said like I can tell you how Julia did it. And you know why he could say that? Because he listened to what his group said, whether or not he was really feeling it or paying attention. So this is good group work because I don't care if you're sitting there and you're like, I don't know how to do it. Okay, ask someone around you. This is the whole reason we sit in groups. That's perfect, beautiful. Let's just go early. Just kidding. Okay. C is the midpoint, right? Summary. C is the midpoint means it's in the middle, which means that AC and CB are congruent. And so therefore I could say side, side, side. Great. Awesome. Okay. Number 2. Taylor.
Number 2. Oh yeah, we know that the little middle point J, the two angles, the vertical angles.
Uh-huh.
So that would that angle would make the opposite side the same as
But that's not one of our reasons yet. The other thing I'm going to say this is that, hey, you have this idea of parallel lines. And like we know all the red angles are congruent and all the brown angles are congruent. If I'm looking at this, what are those two red angles called? They're congruent, I know that, and what are they called? Interior. What's this mean? Not opposite, but close. Alternate. Right? So those two red angles are alternate interior, and that's the same right here. G and H are alternate interior angles because they're between these two parallel lines. So those are alternate interior angles, and now I can say for sure it's congruent because of angle side angle. Okay? Because of angle side angle. What? Okay. You could have also done, there are another option, you could have said that F and I are congruent angles. Okay? What about number 3?
There, wait a minute. With 2, you can't tell they're congruent because it is not known if FJ and JI are congruent and or if FG or HI are congruent.
That's the reason we have these triangle shortcuts. So the point of angle side angle is to say, by knowing this angle, that side, and the other angle, that's enough to say that forces only one triangle that can be made, and so that any triangle with those given measurements is congruent to the others. And we can then conclude, because of that piece of information, that these are all congruent. Their point is that they're shortcuts. These side, 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 all of these things are shortcuts. Instead of saying we have to know all 6 pieces of information. Okay, number 3, I'm going to do really fast. Perpendicular bisector means it makes 2 90-degree angles. Bisector means it cuts it in half, splits it in half, so that ML and KM are the same. And of course, we know that MN is congruent to itself because it's the same. So what is that, Mitchell? Side angle side for the width. Nope, not necessarily. I mean, once we know it's congruent, yes. Before we know it's congruent, not necessarily. But it's bisecting this line, not that angle. Over here, it bisects the angle. Over here, then you have...
Wait, Miss Dalton.
Okay.
For number 3,
What?
could you also do side, side, side for number 3 if you just
You
like I know it's simpler to do the other one, but
You
it's
like if you went again and said because of two sides